Hello students, I am Dr. Rajaram Dhok from Savitribai Phule Pune University affiliated Agricultural Development Trust Shardabai Pawar Mahila College Shardanagar Baramati. Let's start. Today we learn about the valence bond theory for coordination complexes. And in this valence bond theory, in the fourth lecture, we learn about the inner and outer orbital complexes. So what is the inner orbital complexes and outer orbital complexes? So Pauling's theory faces many difficulties when the number of orbitals needed to accommodate the bonding electron that is very too low. And this can result from the occupancy of the orbitals by either the paired or unpaired electron from the metal ions. And to understand that, we can take the example of Fe F6 3 minus. So Fe F6 3 minus and other example is NiNS3 6 2 plus. And these two examples have magnetic moment. In the first example, magnetic moment is corresponding to 5 unpaired electron, and in second there are 2 unpaired electron. And when there is 5 unpaired electron and 2 unpaired electron, then in that case the D2sp3 hybridization of the central metal ion is not used. And in that case, the sp3d2 hybridization is used. And how that sp3d2 hybridization is used and why that is used. And from this, we can explain what is the inner and outer orbital complexes. So you see here, these two examples. In this case, here these 3D orbitals electrons are not used. And it shows 5 unpaired electron. Here sp3d2 hybridization is possible. In NiNS36 2 plus also, these 3D orbitals are not used. Here sp3d2 hybridization is used. And this sp3d2 hybridization, in that case, the nth shell s orbital, nth shell p orbital and nth shell d orbitals take parts. And such hybridization is sp3d2 hybridization. In that hybridization, the outer orbitals are used. So Huggins in 1937 proposed that outer d orbitals might be used in bond formation. However, at that time, it was generally considered that the 4d orbitals could not hybridize satisfactorily with 4s and 4p orbitals of metal to give the strong covalent octahedral complexes or strong octahedral bonds. But after that, Craig showed that with higher electronegativity ligands, the use of 4d orbitals probably forms a stronger bond than those formed by 4s and 4p orbitals alone. So when we consider this, then we say that in generally the inner orbital octahedral complexes that utilizes n-1 d2 ns and np3 orbitals and shows d2 sp3 hybridization, and that is called as inner orbital complexes. In the other side, outer orbital complexes utilizes ns orbital, np3 orbitals and nd2 orbitals and shows sp3d2 hybridization. So this sp3d2 hybridization it forms, and that is called as outer orbital complexes. Here n means nth shell. So we take some examples, and from that example we get idea about the inner orbital complexes and outer orbital complexes. So firstly, we see about the inner orbital complexes. For that purpose, we take the example of CONS363+. So in this example, it utilizes or cobalt utilizes n-1 d orbital, ns orbital and np orbital of the metal and shows d2sp3 hybridization. And when there is formation of d2sp3 hybridization, then that is called as inner orbital complexes. Now we see the how outer orbital complexes is formed, and for that purpose we take example of NiNH362 plus. So in this case, this nickel utilizes Ns, Np and Nd orbitals of metals, and it shows sp3d2 hybridization, and it forms outer orbital complexes. So these inner orbital complexes which can utilizes D2sp3 hybridization, that is also called as low spin complexes, or that is also called as spin paired complexes. So in these inner orbital complexes, here when there is formation of D2sp3 hybridization, then in that case the unpaired electron number is less, and so that is called as low spin. Or in this case maximum electrons becomes paired, so that is also called as spin paired complexes. While in sp3d2 hybridization, the outer d orbitals are used, and in that outer d orbitals, here 3d orbitals electrons remains as it is, or it remains free, or there is not maximum pairing, or so that orbitals or that type of outer d orbital, that is called as spin free, or in that spin free cases the number of unpaired electron is high, so that is also called as high spin complexes. So you remember again that inner orbital complexes, that is called as low spin complexes or spin paired complexes, and outer orbital complexes, that is called as spin free or high spin.